The Euclidean distance server is working fine. This time, let us write the client side that will get response from the Euclidean distance server is working fine. This time, let us write the client that will make requests and get response from the server. So to write a client, you open your terminal, and then let's quickly go to the workspace, and then the package, and then the scripts. So we can quickly create a file, which is, so we're going to call it Euclidean distance client.py. Right, so let's quickly go back to workspace, and then we open VS Code from there. Brilliant. Okay, this is the previous code we had. Now this time around, we're just going to go to the client, and then we start writing our client. Okay, so the first thing is the shebang. USR bin, and then the env. We are writing Python 3. Then you import the necessary libraries. This time there's this library called sys that we're going to import because we want to use some stuff which you're going to see later. Okay, import rclpy. Actually, the sys is because we need to take input from the user on the terminal. So they are going to input their desired coordinates. So that is why we're using this sys for this Python system. Okay, from rclcpy.node, just like we've been doing before, import the node class, and then we don't need the total sim this time. All we need is just our service file. Import the add to it. Okay, so because we're not subscribing to any total sim post, we don't need total sim. This time around, we're just going to create the object-oriented version so that you can see that you can have a publisher that is functional programming, and you have a subscriber that is object-oriented. It doesn't really matter. And also the same thing for services. You can have a client that is OOP, and then you have a server that is just not OOP. Okay, so but then remember, the best way to write Rust code or Rust 2 codes, not really Rust 1 but Rust 2 codes, is through object-oriented programming. So I'm just going to create a class, and then let's call this class client. Client has the node properties. Okay, then we create our constructor. Remember, constructor is this init. Oops. Constructor is this, and then what it does is to take the self object. Okay, so super means this is where we put in the node name. So you can give your node a name, and we're going to call it EDC, which stands for Euclidean Distance Client. Okay, the next thing we want to do is self. You want to create a client object. Okay, and then the client is self.create client. Remember, again, you pass in the type the client is using, which is add to int, and then the topic, or let me use the word, the service name that you want to communicate to. Now this service name must match that of the server so that you can know that they are communicating to the same service. Okay, so distance 2 points, remember that's the name, so they have to be the same. Now what we want to do is we want to check if the client is waiting and if there is communication. So we're just going to say while not self dot client dot wait for services or for service, and then we put a timer to that. Timeout in seconds is equal to 1.0, just like we did for the C++ code. So basically we're just saying that while you're trying to, while you're unable to get, or while you're unable to wait for the service within the period of 1 second, while you're unable to get anything, we want you to say, okay, if not RCL py dot okay. Okay, if it's not okay, meaning that if the ROS client for Python is actually not working at the moment, or we can't see it at the moment, then we want to tell the user that, you know, interrupting the service, and we just want to exit. So just say self dot get logger. Remember how to use the get logger. And you can see the good thing about this OOP way is that you can, you know, easily, even outside of the main function, you can still quickly use your node. So we can use self because we have, it's referring to the node. Okay, so info, then we can say interrupted. Wow, waiting service. So we can say exit. So basically, if this thing is trying to, you know, communicate or wait for the service, then, and you cancel ROS, or let's just say you press your Control-C to cancel ROS, and, you know, the client library for the Python is not working anymore, it's just going to tell us that, you know, something interrupted the client library for Python, and it's been interrupted while we're waiting for the service. So if that's not the case, if the ROS client library is still working fine, but then we are still not able to get something from while waiting for the service, then we want to say this. We want to say that get logger. Then you have your info. So we want to say service not available. So the service is probably not available because the client library is working, and then we are trying to get the service and we couldn't get it. So service is probably not available. So waiting again. This is just the same like the C++ code we had the other time. So I'm just going to create something now, which is the request. We're going to create a request, and what the request is going to take is add to int dot request. Okay, so add to int dot request, and then we store it inside request. We're going to leave that function, go to the next one, we leave the constructor, we go to the next one and create a function called send request. So this is the function that gets the request from the user. So you can input the request on your own terminal. So it's going to get the request from the user, imputing it on the terminal. And then put in the self. All right, so self dot request, you know, the work of the self is that it means that you can use that self to access any variable outside of this function as far as they are in this class. So you can use the self object to access them outside of this function. So request dot, so there are different things in request. We have the A and B. So we are interested in the A for now. And then we say system. So okay, well, anyways, let's do it this way. We're going to cast it as an integer. So we want to take some arguments from the user. So this is where the user is going to put in their own desired coordinates. So when they put in the desired coordinates, which is argv1, the argument vector, okay, so the user is going to impute the argument vector 1. So let's say, for instance, you just input 2. Even if you type 2.0, it's going to cast it as an integer and just make it 2 instead of 2.0. So that's the function of the int here, just to make sure that whatever you type, we're casting it as an integer, and then we're storing that value inside A. And remember, A is inside request, okay? And remember, request is an instance of add2int request. All right, so we move on. Self dot request again. So we want to take B, which is going to be the second one. System.arg B, the argument vector, and then 2. So we're saying that you should always put in 2 arguments, and then it's going to take the 2 arguments, put it inside A and B respectively. So the next thing is self, but we now want to make something called result. So what is result? Result is self.client, self.client dot call. Remember, this is the client we created here. Okay, so self.client dot call asynchronous, and then self dot request. So it's gonna get the request and then make an asynchronous call using the client, and whatever it is, it sends it to, we input the results to request. Okay, so now let's create our main function. So main function is going to go like this: def main, and args is none. Then the first thing we want to do again is what? Initialize your node. Okay, so you want to initialize your node, RCLC, sorry, I'm always used to the C++ version, dot init. So you want to initialize your node, SQL args. Then the other thing is, what if the user didn't even impute anything like the pose? What should we do? What if the user imputes more than 2 coordinates? What should we do? So that's the next thing I want to write now, just like it's in the C++ version. So we're just gonna say, you know what, we want to take the length of the argument. So meaning that the argument vector is going to be, it's what we need is 3, because your file itself, your programming file itself already takes 1. So then this next 2 here are the ones we want to take from the user, making 3. So if the length of that argument is not equal to 3, then we want to throw an error. So if the length of that argument is not equal to 3, we're going to say print impute 2 coordinates. So impute 2 coordinates. So it's just gonna tell the user that, you know, it's like you're doing something wrong. Impute 2 coordinates. In fact, I think I should, let's put an error here. Error or warning, you know, something like that. Yeah, something like this. So warning, impute 2 coordinates. Now we can say system.exit. So it means that when our code gets to this part, if this part of our code should run, then when you input something that is not 3, then it's gonna just print out warning, input coordinates, and then the whole program, the edc.py, will shut down. So it's just going to exit the old program. So then you can, have the opportunity to type your stuff again. So what we're going to do now is to create the client, so we're going to store the client inside distance client. Let's just call it that way. It doesn't really matter. And then we want to do distance client, since this is the client side of the code, dot send request. Remember, this is the send request. So it's more like we want to run the send request. Okay. Now, while raw CLPY is working, that is, while ROS is okay, we want to do something. The first thing we want to do is to spin your node. So the first thing is to spin your node, spin once, and then whenever you use ROS CLPY.spin, the question is, what do you want to spin? You want to spin the node, this client. Okay, we are now gonna have if this client dot result. Now this is always a Boolean variable, so we are saying that if it's able to get a result, so if we spin and then we are able to get a result from this client, then this is what we want to do. So if the done returns a true, more like a success, a true or something, this is what we want to do. What we want to do is to write a try except. So try response is response is equal to distance client, that's the node, dot result distance response is equal to distance client dot results. Okay, dot results. Now you should not confuse this. This result here is the one we have. Oh, there is a mistake somewhere. So this should be results. This should be results. So we want to take the request and then we call the asynchronous server, the asynchronous client, and then whatever happens, we put it inside results. Okay, so now we're saying that if distance client, if it's able to get this result, if it returns done, which is actually going to return a Boolean variable, true or false. So if it returns done, which is true, then we want to take that and put it inside a new variable we're creating called response. Remember, what should be and what is inside response is what the sum. Okay, so we're creating result dot result. Now this result, the first result here is this one. This second result is from ROS. This one is the one we created. This one is from ROS, which takes the response from what the client was able to get from the server. So it's going to put it inside response. Okay, we just created this response. You can decide to give it any other name. So, but in this case, it's just response. And then what we want to do is to get the response. When we get the response, we want to do something with that. And what we're going to do with the response is this. We're going to write an exception. So exception as E, and then we put in the message. We want to log in a message. So the first thing is to use the node distance client dot get logger. Remember, without a node, it's not going to work. And then dot info. And then we put in our message. So if that thing fails, we want to say failed to call service. Okay, failed to call service. You can use your placeholder again to put in the exception. Okay, use the placeholder to put in the exception. And then we'll write the else distance client. This is where we want the user to be able to get a kind of feedback. No, not get logger. To get a feedback, and the feedback is gonna be distance between poles. Okay, yeah, distance between poles. Now, when I say distance between poles, that's the total poles, and our own desired poles is gonna be this, which is response.sum. Okay, response.sum. Remember, this response is now that response that we have in the server code. So response.sum. So it's just gonna say it's gonna get the result. When it gets the result, it stores it inside response. So from there, we can then access, you know, the response can be more than what is inside the response can be more than one. You can have 2, 3, 4 responses. It depends on how you want it, but it's going to store it inside response. And then we want to access just the sum part, which is actually the only thing we have in response. So just going to access the sum and say distance between poles, and then instead of this d, this is just a placeholder for response.sum. Okay, so after doing that, we want to break out from this. So when you get that, just break out, and then we destroy the node. To destroy the node, you just do distance client. So if you do not destroy the node, it's just going to be taking unnecessary space. So you have to destroy the node, and then you shut it down. That's if something like Control C is called on your keyboard. So what we want to do now, your guess is right, is to do the name equal main. And we're just going to call the main function. Yeah, and that's all. Hopefully everything is right. Again, the first thing is to import the necessary libraries, and this is the one that will help us to handle the inputs from our terminal. Okay, so remember, object-oriented programming is always the best for us too. Without it, you're just going to make things very complicated. Okay, so we have this one here, the node. So what a node is doing is we have the class called client and have access to the node object. So we declare a constructor, and then we pass in the name of the node, which is called EDC. We create a client. The way to create client is just to do self.create client. You put in the type that the service is using, and then the name of the service itself. Okay, so this one, we're just using it to check if ROS is working and if we're able to get the something from the service server. So, and then we create an object or an instance of add to int request. Okay, so this instance, we need it here, and we also need it outside of this place. Okay, so what we're just going to do is we tell the user, we get whatever the user inputs using this, and then we we cast it into an integer. If it's a float, we're going to cast it into an integer with this int. We get the second input from the user with this, and then we cast it also into an integer. We store both of them inside the response A and B respectively. So we call the asynchronous client on the request, and whatever it gives us back, we store it inside result. Okay, from there we initialize our node, and then we check if the arguments imputed by the user is actually 3 arguments. If it's 3 arguments, of course they are going to put in 2 arguments plus the extra one that is reserved for the code. Okay, so it's going to be 3. So we're going to print 1 in input 2 coordinates, and then we exit out of this program. Okay, so we create an object of the client. We make call send request on it. We spin we check if Ross is okay. While Ross is okay, then that's when we want you to run this code. So we spin once, we spin the node once. So when we spin the node, then we want to check if it's done, like if it was successful getting, so this is going to return a boolean. So if it's successful getting something from the service, we want to take the result of whatever it gets from the service and stores it inside response. So when it stores it inside response, then we want to print it out and say response.sum. Else, if it was not able to do that, then we want to say failed to call service. Okay, when we're done with that, we destroy the node, and then we create a function that allows users to be able to shut down the node. After that, we put all this main function here inside line 47, and then we're good to go. So you're going to save this file, and then we go to a CMake list to configure the service client node. We already have the example interfaces, and then what else? We just need to add it here. So we add the script /edc this time, and then we save. We go back to the terminal. We run Calcon build. If there's any error, Calcon is going to tell us. Okay, so no error. We source. Let's source our workspace. Install setup the bash. Okay, sourcing done. Now to use this, we need to call our client first. Remember, without calling the client, it's not going to work. So we need to do ROS2 run. What do we want to run? We want to run the total control, and then we want to run the eds.py. Okay, so our server is running now, waiting for a client to make response, to make request. So we're going to source this now. Set up the bash. Now that we've sourced, let's try to make request ROS2 run, and then talk to control. So the next thing we want to put is the name of the node. So in this case, it's EDC. This is for the client. Now I'm not going to put in any argument. So I just want to see if that part of the code will run. Okay, you can see it says warning, input to coordinates. So it means that I have to pass in 2 arguments for this to work. So I'm just gonna go back again, and then let's put in 3 and 9. Okay, great. You can see distance between poles 9, while the server just tells us that ready to get distance between 0, 0 and 3, 9, and then it calculated the distance and then gave us 9, which was returned here. All right, so but there's something wrong here, and what is wrong is that our TotalSim node is not yet running. So let's run the TotalSim. I'm just gonna do ROS2 run TotalSim, sorry, and then TotalSim. All right, now that the total is running, we should see now that the initial pose, the pose of the turtle that was here before, should change from 0, 0 to something like 5. So it's going to get the real pose of the turtle now, and then make cal calculate the distance again. So I'm just going to run the code using the same 3 and 9, and let's see. So you can see now the incoming coordinates are 5, 5, which is the coordinates of the turtle, and then we have the pose, or the distance between the 2 points, returned as 4. So what I'm going to do now is to run the tally-up key node, ROS2, run turtle sim, then the turtle tally-up key. Now, the reason why I'm doing this is because I want to move the turtle around and then see whether it's going to get the pose. So I'm just going to move the turtle. Let's move it, anywhere. Okay, let's stop there. And then I'm going to run it with different numbers now. Let's say 4 and 3. Okay, you can see now the position as the turtle is at position 1, 1. So basically it's just, converting it to an integer, it might be a float or double, and then it's returning a distance of 2. Okay, so that is how services and servers, or service clients and service servers work. So basically, a service client makes a request and the service server responds to that request and returns something to the service. Okay, so we've done this in C++, and this is the Python version. In the next lesson, you will see how you can create a custom service file for your node.